Okay, this one, f of x equals x minus 5 over x squared plus 4x. Again, find f double prime x are the directions. And we can see here, as far as structure is concerned, it's pretty obvious. It's a quotient. Okay, it's an explicit function. I forgot to really harp on that too much. We just got it out of implicit functions. Now we're doing explicit functions again. We're going to do implicit differentiation with second derivatives here in the next couple of days. We're doing explicit functions today. But f of x equals x minus 5 over x squared plus 4x is a quotient, so obviously the quotient rule is necessary. The quotient rule, which is low d high minus high d low over the square of what's below. That's the quotient rule. And keep in mind that this is a derivative and this is a derivative. Nothing else is a derivative there. It's just a matter of writing down stuff. Low means the bottom, high means the top. Okay, d low means the derivative of the bottom, d high means the derivative of the top. So again, I've got my structure here of what the quotient rule is. I got these different colors here so you can see where things are coming from. If we take a look at the top and the bottom of the function in this case, the top of the function is x minus 5. It's just a polynomial structure. The bottom of the function is x squared plus 4x, also just a polynomial structure. So it's a pretty basic, easy structure. Okay, derivatives will be 1 and 2x plus 4. Okay, not too demanding if you ask me. So if we go ahead and do this, f prime of x equals, I want that to be blue. F prime of x equals. So again, I'm going to the quotient rule. I'm using a calculus technique. So I'm changing f of x into f prime of x. I'm doing calculus. Again, you want to start at least mentally telling yourself, I'm doing calculus, to change the f. Okay, I'm doing algebra, don't change the f. All right, so just make sure you know what you're doing. Whether it's the calculus, if you're applying a calculus rule, you're doing calculus. F changes to f prime. I'm not doing calculus. I'm just monkeying around with all the objects. I'm doing algebra. F prime stays f prime, or fx stays f of x, that kind of stuff. So, quotient rule. Make a big long quotient bar there. Allow myself some room to write stuff. Low, bottom, x squared plus 4x. How many objects is x squared plus 4x? 2. Put parentheses around it. Anytime you're doing the quotient rule and you have more than one object in one of the pieces, this piece or this piece or this piece or this piece, and more than one object, put parentheses around it. D high, what's the derivative of the top?
1.
How many objects is that?
2.
1?
1 minus.
Don't need parentheses around the 1. Alright, so again, as you write stuff down, if you need parentheses, do it. If you don't, don't. Alright, that's one place where some of you are messing up right now with the quotient rule. You write x squared plus 4x times, let's say it's times 2. You don't have the parentheses, you just double that one, don't double that one. Alright, so again, x squared plus 4x, multiple objects, parentheses, one object, don't worry about it. This minus sign is just part of the rule, so I'm going to put that minus sign there. This is part of the rule. Okay, high, what's the top?
X minus 5.
How many things is that?
2.
2, so we put parentheses around it. X minus 5. D low, the derivative of the bottom is?
2x plus 4.
2x plus 4, how many things is that?
2.
More than 1.
More than one, so parentheses. Yeah, it's real simple. If there's more than one thing, parentheses go around it. If there isn't, then you don't need to worry about it. All right, so low, bottom as it is, D high, derivative of the top. High, top as it is, D low, derivative of the bottom. Over the square of what's below. So that's just going to be x squared plus 4x. The quantity squared, because it's more than one thing in parentheses. My advice is leave the bottom just like that. Okay? If it can become prettier, that's fine. We'll worry about that in a minute. But for right now, while you're fixing the top, just leave the bottom as is. All right. Now, I'm going to go from here to here by beautifying this expression. What am I doing in order to do that? Algebra or calculus?
Algebra.
Algebra. If I'm doing algebra, f prime of x stays the same. For me, for a time saver or space saver, I do this within my work. Okay? I'm going to make this x squared plus 4x, and I'm going to multiply this out. That's 2x squared, and then 4x minus 10x is negative 6x, and then minus 20. I go ahead and keep them both in parentheses. X squared plus 4x is still 2 objects. 2x squared minus 6x minus 20 is 3 objects. Again, multiple objects I'm putting in parentheses. There's a minus sign between, but again, I just go ahead and do these things here if they're not really challenging. one time something not very challenging. FOIL at this point for you guys shouldn't be very challenging. Okay. Then I distribute this minus sign through, and this is where the parentheses are going to disappear. And I can treat everything as single objects. So I got x squared plus 4x minus 2x squared plus 6x plus 20 all over x squared plus 4x, the quantity squared. Again, distributive property, FOIL. Here I'm going to combine like terms. Those things are all algebra techniques, so I'm doing algebra. I'm continuing to do algebra here with like terms. So it gets me negative x squared plus 10x plus 20 all over x squared plus 4x, the quantity squared. And that is my first derivative of this function, this polynomial function. Or I should say this rational function. Any concerns with any of that work for anybody? I'm going to group all this stuff together and shrink it down and get it out of the way so we can do a second derivative. Bring it over here, bring this up here. And now we've got this guy. X squared, negative x squared plus 10x plus 20 over x plus 4, the quantity squared. And again, I've got a quotient, top over bottom, right? So I got to do low d high minus high d low over the square of what's below, right? The same rule, all right? What I want you to see here is the d low part. This is an x squared. Did I have that written?
It's x squared.
I know it's x squared. Did I ever have it written?
I don't know.
I hope I did. As I was moving things around, it just disappeared, but it would still be down here. But oh well. Pretend that x squared was there the whole time. X squared plus 4. The d low part is x squared plus 4x squared. This is a chain rule situation. So I'm going to do the quotient rule again, low d high minus high d low. But when I do d low, quotient rule. When I do d high, power rule, right? So again, what rules are necessary to differentiate? You have to establish that before you start differentiating. Don't just start writing stuff down. Think it through, understand what it is you need to do. So I'm going to go from here to here using the quotient rule to differentiate this thing. That's a calculus rule. I'm doing calculus, so f prime becomes f double prime. Make a big quotient bar. I'm anticipating this one to be a little bigger than the last one. Okay, if we do low d high, so low x squared plus 4x the quantity squared. D high is the derivative of the top, which is negative 2x plus 10. How many things is that? 2, so parentheses have to go around it. Minus is just part of the quotient rule, it has to be there. And then high, which is the top exactly as it is, with multiple objects again, so parentheses negative x squared plus 10x plus 20. D low, and again, low is this expression here. This is a power structure that I have to use the power rule to differentiate, but then it's a composite function, so the chain rule has to continue on from there. So 2 times x squared plus 4x to the first times 2x plus 4. So what's in red here is the derivative of the bottom using the chain rule. So the power, the base to one lesser power, derivative of the base, over the square of what's below. That's just going to be x squared plus 4x squared squared, which is going to be to the fourth, right? Now, we can look at this and be a little bit intimidated by it, or we can think it through. Something that's going to happen every time on this when you do the chain rule in conjunction, or I should say second derivative with a quotient. Okay, this happens all the time. It's not uncommon. All right. The function here, the first derivative came down to a second power. The third derivative should come, or the second derivative should come down to a third power, but it came to a fourth power. Okay, that's what happens every time you do the quotient rule, or I should say derivatives with a quotient. If there's a power on the top or bottom, the top power is going to go up by 1, the bottom power always goes down by 1. That's just what happens. All right. This power went down by 2, which tells me, because I'm used to this, and hopefully you guys will become used to it, that every one of these objects, this is a term, so this product makes one term, this is a second term, this always makes the second term, and this is the third term. It tells me those three terms have x squared plus 4x in common. Notice, x squared plus 4x, x squared plus 4x to the second, x squared plus 4x to the fourth. The lowest power there is 1, so I'm allowed to take an x squared plus 4x to the first off of every one of these. That makes this go away completely. This power drops by 1, this power drops by 1. That is legal, and it always happens when you're doing a quotient rule second derivative. And if I do a third derivative, if I square that, I'm going to get a 6, right? I'm supposed to get a 4. Guess what I can take off of that one? X squared plus 4x squared. It'll show up. It'll be there on every single term. All right? So, now if I start simplifying this thing, I'm doing algebra now, right? So f double prime of x, not changing that structure because it's still algebra. This FOIL is a little uglier than the last FOIL was, so maybe I'm just going to go ahead and do this in pieces. So x, this is to the first, this is to the first, that's just basic binomial multiplication. X squared times negative 2x is negative 2x cubed. X squared times 10 is plus 10x squared. 4x times negative 2x is minus 8x. 4x times 10 is plus 40x. For this one here, I would probably say that's 2 times this, so that's going to be 4x plus 8 for these two guys. Everybody see that okay? This is being multiplied by this, and again, it's just polynomial multiplication. 4x times the entire thing, 8 times the entire thing. It is minus, I would do minus parentheses and do the multiplication. So 4x times negative x squared is negative 4x cubed. 4x times 10x is positive 40x squared. 4x times 20 is 80x. 8 times negative x squared is minus 8x squared. 8 times 10x is plus 80x. 8 times 20 is plus 160. This minus sign is being dealt with afterwards, so notice I put minus, I put a parentheses. When I multiply this, I pretended that minus wasn't there. I just got the signs I got from multiplying those two guys. The bottom is going to continue to be x squared plus 4x cubed. All this minus sign is going to do is change all these signs to their opposites, right? So if I make that a plus, that becomes a plus, that becomes a minus, minus, plus, minus, minus. Then I can pretend the parentheses aren't even there. So my final result here, f double prime of x, continue to do algebra by adding like terms. I've got negative 2x cubed plus 4x cubed makes positive 2x cubed. I got 10x squared. This should be 8x squared, shouldn't it?
Yeah.
10x squared minus 8x squared is 2x squared. Minus 40x squared is minus 38x squared. Plus 8x squared is minus 30x squared. 40x minus 80x is negative 40x. Minus 80x is negative 120x. And then plus minus 160. All over x squared plus 4x cubed. Hope we don't have to do a third derivative on one of those. Yeah, pretty ugly. All right. The challenge of these problems is the algebra involved after the calculus is done. Just a matter of carrying through properly.